Hey everybody. It is time to do a video on the end behavior of polynomial functions. It's one of those topics that when you first look at it, I think even when you look at the notes, it's like, this is, no, this just, no, I can't do this, too crazy. But have faith. I have a feeling that once you watch the video and see a bunch of examples, it's actually not going to be that bad. This is kind of the first section of the last chapter of Math 30. So we're almost there. All right. So first of all, a polynomial function is one that's going to start out with y is equal to something or other. There's probably going to be an x squared plus a 2x minus 6, or y is equal to 5x, or y is equal to minus 16x to the 10 plus 12. Minus 2x. I don't know. It really doesn't matter, but it's going to be y equals something. You're going to have some x's on the other side, and it really doesn't matter what it looks like. As long as you have whole number exponents and there's no weird logarithms or, what's the other one? Fractional exponents in it, we're golden. Okay, so we're getting an equation that looks like that. So that's a polynomial function. All right, second thing, you have to know this. If you have a Cartesian plane, it is divided up into, sorry, you're looking fuzzy. There we go, 4 quadrants. And they're numbered like this. And they're always numbered like that. It always goes, let's see, the counterclockwise, starting in the top right-hand corner. So if you have to do end behavior or characteristics of a polynomial, right? First thing I do, actually, 2 things I do to start. I take my handy dandy highlighter and I highlight my x-axis and my y-axis, because usually there's a graph drawn on there and there's grid lines and it gets all confusing. So I label them and I put my numbers in. So if you get a big assignment, say you've got 5 or 6 of these to analyze, just do that at the start. That's what I do all the time. Then you're not having to mess around in the middle and trying to remember which way did those numbers go? Did I get that right? Right? Let's make life easy. The next thing you need to know is you always read your graph. Just like you would read a sentence. You're going to go from the left to the right. So if I'm reading this graph, if I'm going to talk about this graph, I start here and I go in this direction. Well, we're talking about the end behavior. We need to know where a graph starts and where it ends. If I'm reading in this direction, go this way, those are the only 2 possibilities for a start, because it has to start on this side. So my start is always 2 or 3, and my end is always going to be 1 or 4. That's it. It has to end on this side. It has to start on that side. So far, so good, right? I'm going to take you back for a moment to your fundamental counting principle. If there are 2 places that it can start, and then we have to figure out where it's going to end, and there's only 2 choices there, there's only 4 possible combinations, right? That's it. You can handle 4 things. So it can start in 2, and go to 1. Let me just draw a quick graph. I could give you a graph that starts here and goes like that. So this is 1 and this is 2. Start 2 and 1. You have to do that, but I did it once. All right, so it can go, basically it's a cross. I can start in 2, and I can finish down here. I draw my graph a little smaller so I can get them all on the page. And that could be a graph that goes like that. So 1, 2, 3, and 4. See, it's bugging me. 3 and 4 over here. And you know, did I not just say? Highlight it to make it easier to see. So this is start into end in 4. So what I'm looking at, and we did this the other day in class, I'm looking at this point right here. There's my start, there's my end. What quadrant? What quadrant? Right? That's it. Don't overthink this. There we go. Look. Starts in 2, ends in 1. And my camera for you. Okay. I'm not going to tell you which one I'm going to draw now. While I am doing my happy little highlighting thing, I want you to figure out where the start is and where the end is. And go back and look at what the options are. Okay, now, I wish I could hear you on what you were saying right now, because either you're going to be really happy or you're going to be mad at me. When I'm reading a graph, I go this, whoops, I forgot the one last thing. You can only start in 2 or 3. I know I drew it backwards. Okay, so this is my start. It's 2 or 3. So this starts in 3. And it ends in 1. So just look at the 2 end points. So you got your start and your end, and you'll be fine. So the last option, just so I have it all on this page. It's going to come from down here. And I can do that. By the way, they don't always have to cross through 0, 0. Apparently today I'm just making that happen. All right. There's my axes. There's the ends of my graph. And 1, 2, 3, 4. So this one, you still see it? Yep. Start in 3, end in 4. Some people are really clever and they can memorize stuff as to what kind of equations go with each sum. I'm not that person. I just have visual things that help me. First of all, there's kind of 2 types of questions you're going to get on this. And this will apply both for this section and the next one on polynomials. If you're starting with a graph, I think this is pretty straightforward. Okay, I'm going to stop my share. Don't worry, I'm not running away. And I'm going to show you my favorite website. Hope I can find it. Read that, Desmos. Desmos Graphing Calculator. If you have access to the computer when you're writing an exam or doing your assignments, use Desmos. Don't make life difficult. So you bring it up. And there we go. Okay. So if you have a picture, sorry, okay, so if it's something I drew or something on Desmos or something I've copied, it's pretty straightforward. Well, you know what? We're just going to start right there. So hold on a sec. I'm going to make a few adjustments. When I use Desmos, actually, I shouldn't have done that so fast. There is a little wrench in the corner. Okay, I make sure it's on grid. I have axis numbers. And I also change these steps to 1, which makes my numbers nice whole numbers. And it's just easier for me. Hold on, maybe I can do one more. Oh, I don't know if that's easier to see. There, ooh, there, that's nice. Okay, so there we go. It's an equation. Here's my equation over here. This is what I like at Desmos. You would probably just get this picture. So I am going to quadrant 1, quadrant 2, quadrant 3, quadrant 4. And here are axes. I'm not going to highlight them because they have all the numbers on them. All right. So this equation, where does it start? Well, we can't see, but it starts down here and ends up there. So it starts in 3 and ends in 1. I am, in case anybody's wondering, I'm just randomly making stuff up. So if you want the keypad, it's down here in the bottom corner. Okay, so X. Now I'm going to make it X to, I don't know, the 5. Minus, I don't know, X3. Whoops, got to be careful. You got to press that button to get an exponent. Plus 12. Oh, I don't think I want that part. There. Use that. Another nice thing with Desmos is I don't want that red line anymore. Oop, it's gone. Oh, now I need to erase those 2 dots from last time. I should have. So we are now looking at this line. And if I'm coming from this direction, my graph is going to start here. And it's going to end down there. So that is starting in 2 and ending in 4. Ta-da. So if you have a picture of the graph, I think it's pretty straightforward. Okay. What happens in the middle doesn't particularly matter. Let's see if I can. I don't know what's going to happen to my graph if I do that. No, not much. It's a little change, but nothing too exciting. If I had an x squared on the end. Oh, no, I like just a plain old x. See, we're starting to get a lump in the middle. It's all the same. It's still starting here. No, get rid of that. And ending down here. My point is there's a lot of graphs that are going to start up here and end down there. Okay. If you want more practice with Desmos, you should talk to me and we can do it one-on-one. What I do want to show you though is what happens when all you're getting is an equation. So I'll stop my share. Okay, so if you have an equation, so starting from the picture, I hope you've got that cased. If not, let me know. We can do more practice. But Today's not the day for that. Okay. So I'm going to say end behavior from equation. But I'm going to tell you the first thing is if I have equation, so y is equal to minus 6x to the fourth plus 15x3 minus 12x10. Truth be told, if I have access to Desmos, I'd probably just put it in Desmos and print it off. You know what? I may regret this, but let me see. We're going to do a lot of camera sharing today, which sadly means you just get to randomly stare at my face while I figure this out. All right. Ow. That didn't work. This one, share. Okay, back to Desmos. So the equation I had, let's get rid of this stuff, is y equals minus 6x. I need this part to get to the fourth plus 15x cubed. Click on there again. Minus 12x to the 10. Ah, that's a cool graph. So really, once you've got your graph, ta-da, we are going to start down here in quadrant 1, 2, quadrant 3, we're going to end in 4. But as I said, you also need to memorize or know what happens when you can't graph it. But it's a nice one on an assignment or something. If I don't give you the picture, you could always just graph it. Okay, back to where we were. So to get the end behavior from the equation, you have to be able to do a couple of things. Okay, you have to be able to find the leading term. And the leading term is the one with the biggest exponent. I don't care. Now, let's make sure we're all on the same team here. My exponents are 4 and 3 and 10. Little numbers up on top. Okay, so my leading term is the one with the biggest exponent. So this is my leading term. I'm just going to call it LT. Oh, I wrote it all nasty. Minus 12x to the 10. So we need all parts of it. We need the sign, if there is one in front of it. We need the coefficient. We need the x, and we need the exponent. And I think what I want to do is a few more examples to make sure you can find the leading terms. And then we'll worry about what to do with it. All right, so y is equal to so I'm going to write several. And I'm going to focus my camera again. And I want you to write out the leading term. Okay, so pause it, write them out, do it, and then turn the camera back on, or turn the video back on. All right, so the only thing we care about is my exponent. So in this one, I have an exponent of 3 and 2. So ta-da, that's it. My leading term is 4x to the third. If you want to put the plus, enjoy. You don't need to, but the sign of our leading term is going to become important later. So that's not a bad idea. All right, so now we got y's. There's a whole lot there, but all I'm concerned about, an exponent of 3 and 2 and 4. Okay, I'm just going to circle this whole bit. There we go. There's my leading term. So plus 12x to the fourth. There ain't much there, is there? All I've got is my leading term obviously is x. That's the only term there is. And our last one should be, I got an exponent of 5, 3, and 4. There we go. I guess in truth, I was just thinking as I'm doing this video, you really don't need to write them out. You just need to circle it. But, hey, it's okay. The other thing we need to know is we need to know the sign, and we need to know where the exponent, which technically is called the degree, but the exponent is odd or even. This will get compared to a chart, so don't stress. So I'm going to put a line over here. Oh, I'm not sure this is going to make it any better. Okay, so this guy, the sign is negative, and my exponent is even. Okay, so the negative refers to the sign of my leading term. The even is referring to the exponent. This one is positive and odd. It seems really weird, but I don't care about the 12. And I really don't care about the 4. It's just whether that coefficient is positive or negative, and whether my exponent is odd or even. All right, pause the camera, do the next two. All right, so we got positive, odd, even, right? That's what we're looking at. This one. All right, I can see it's positive. What is the degree? If you remember, there's always an understood 1 there as an exponent. We just never write it. It's like having a 1 out in front of something. You don't write that either. Mathematicians are generally lazy. Shh. Don't tell them I said that. And my very last one here is negative, and the 5 is odd. So there's your sign, and there's your exponent. Like I said, in the notes, it says degree, but same difference. All right, now, once you have this information, all you do is compare it to the chart. And the chart is in your notes. And it is right there. And I'm now sad that I wrote all over it. Let's say I'm just going to get rid of this. Okay. So I think what might be confusing people is the whole visual aid thing, but it's the only way I can remember this stuff. If my degree is odd and my leading coefficient is positive, it's the same as a line that goes uphill. So that means I'm going to start in 3 and I'm going to end in 1. But what I remember is odd positive is uphill. I don't remember any of that stuff. I just remember if it's uphill, I can draw that and then label my little quadrants and go from there. All right, so odd negative is downhill. So if it's odd, it's a straight line either uphill or downhill. And I kind of like the fact that this one, if you go this way, it's like uphill, it's positive, positive is uphill, negative downhill. Okay, if it's an even, if it's an even degree and positive, it's a smiley face. I mean, it's an upward facing parabola, but to me, it's a smile. And if it's even and negative, it's a frown. And this provides us with all the different ways that we can start and end. Remember, we said there was 4. And if we go back to this page where we started, it's all there. All right, this little bit you have to memorize because you're not, I can't guarantee right now that you are going to have access to Desmos when you write your final or do your assignments on this. It's a little chart. Memorize it. So odd positive uphill, odd negative downhill, even smiling and frowning. If it's an even positive, it's a smile. If it's an even negative, it's a frown. So let's go back to these ones. And I'm kind of regretting how I formatted this because it's going to be messy. All right, you know what? I'm going to do it down here. I'm going to rewrite. So minus, oopsie, can't see that. 12x to the 10. That was our leading coefficient, and we figured out that was negative and even. There's a negative. There's the even. That could be a 3, and it would still be the same. Okay, so I know even, this is how my mind remembers it, is either a smile or a frown. And the negative one is the frown. So 1, 2, 3, 4. So that is going to be my start is 3. My end is 4. That's what you need to know. So when, oh, here we go again. Stop the share. When we posted this one, this is the same one, okay? And we just predicted on our sheet that it was going to start in 3, and there it is. And it ends in 4. Now, this shape is not the frown I drew, and that's okay. That frown is just my guide to remember what happens. But it does tell me that I'm starting down here, and it does something or other in the middle. I don't care. And it ends up back down here. That's what I'm looking for. Where's the start? Where's the end? Oh, okay. Working on the computer, just realized I don't need that flash of my face. Okay, our second equation, the leading term was 4x to the 3. So we said that is positive and odd. There's my odd, there's my positive. All right. Well, the odd ones I remember are just straight lines. So it's either uphill or downhill. And the positive part says it's going to go uphill. So, whoops. I'm going to try and remember to do that all the time because my sketches aren't great. So that reminds me where my axes are. And then 1, 2, 3, and 4. So my start is in 3, and my end is in 4. And there we go. Ta-da. Which other ones do we have? Okay. The next one was, my leading term was 12x to the fourth. So that's going to be a positive and even. So I remember even is a smile or a frown. Okay, it's a parabola, but smile and frowns works for me. And it's positive, so yeah, there's my sketch. And I did it off center on purpose. It doesn't matter. One, two, three, and four. Room, start, and two, and four. You know what? I'm going to graph that one. It's kind of a cool looking equation. All right, make that go away. So this was the third one. Y equals -7. Whoopsies. Hello. Y equals -7 plus 2x. Makes it to this, to the third, plus 7x squared. You can see as I keep adding stuff, the line keeps doing crazy stuff here. Plus 12x. Oh, let me run into trouble with what my graph's going to look like. Minus x. Okay. Oh, no. All right, we had to zoom out a bit to see it, but here it is. Just like we said, it's starting in 2 and it's ending in 1. So remember, here is our one axis, here's the other one. I thought it was kind of cool though. Oh, whoops. Can I come back? That partway through this equation, when I just had that much, it was way more interesting. It had that nice little curve in there. And the reason for that is by taking out that x to the fourth, this 2x to the third is now my leading term. And that is an odd and positive. So that's uphill. Oh, there, that's how it should look in the video. So we're starting down here and we're going up to there. So it really is determined by that leading term. All right, back to the worksheet. The next one we had is y is equal to x. So we said that is positive and odd. So my graph is just going to be a straight line that goes like that. There's my x and y axis. 1, 2. So it's starting in 3. And in, up there in 1. Right, because we can, I forgot to do them on these pictures. Just put little dots. Oh, you could also see, sorry, or I put the arrows. That's going to be the same. All right, the last one we had, you know what, I'm going to squish it over here, is minus 18 x to the fifth. So that's going to be negative and odd. So odd reminds me it's a straight line, and the negative part means it's going to be going downhill. So it's going to look like that. Generally. There's my axes. Here's the ends of my line. Start is in 2, end, and 4. Ta-da! There we go. So you need to memorize this. Okay, so it's your visual aid. Like I said, there are some people that are cool and they can remember that an odd degree positive starts in 3 and ends in 1. I'm not that person. I just remember it does uphill and I have to do that little diagram. If I was doing a test or something, what I would probably do is make myself a chart. And you know what? I would make it before I even started doing the test. Not like that, I wouldn't. Sorry. It's my smiley face. This is my frowny face. And this is uphill. And this is downhill. And if you wanted to, you could even, well, might as well do it right. So this is 2 to 1. This is 3 to 4. Let's see, this is, well, I'm doing it again. 3. By the way, if you're really struggling with the Roman numerals, I don't mind if you write them as normal numbers. The reason the quadrants, I think, I've never actually found a reason for that, is I just think if we're not using Roman numerals, there's so many numbers, they're just going to get confused with coordinates and stuff like that. Anyway, this one is 2 going to 4. And there we are. That would be what I would have either on a piece of paper or I would write as soon as I walked into my exam. And I think that's the end of the video.